going to take a look at how to find the distance between 2 points in a three-dimensional coordinate system. You might be familiar with how to use the distance formula in a two-dimensional coordinate system. 3 dimensions isn't all that different. It just adds an extra little piece to the formula. So the distance formula, d equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. That's our formula for our distance in 2 dimensions. We just add this extra quantity here where we have the quantity z2 minus z1 squared to the formula. So every point in a three-dimensional coordinate system has an x, a y, and a z coordinate telling you how far, maybe for, like if I wanted to just pretend I was the kind of the origin in a three-dimensional coordinate system, I could go so far forward or backward, I could go so far left or right, or I could go so far up or down like that. So those are the 3 different coordinates that we're dealing with in the system. So here's the formula. Let's take a look at how we can use it to find the distance between 2 points in a three-dimensional coordinate system now. So here's an example problem. We have point A, which is this order triple 2, 0, negative 3, and point B, which is this order triple negative 5, 3, 7. And we want to find the distance between those 2 points in a three-dimensional coordinate system. So let's go ahead and set this up and say AB equals, again, that's our notation for the length of segment AB, which would be the distance between A and B, making a connection to geometry there, is equal to the square root of x2, which is negative 5, minus x1, which is 2, that quantity squared, plus y2, which is 3, minus 0, which is the y1, that quantity squared. And then finally, the part that makes it different now that we're in 3 dimensions, we also have a z-coordinate. We do the same thing there. We have z2, which is 7, minus z1, which is negative 3, and we have that quantity squared as well. Working to simplify this, this becomes the square root of, that becomes negative 7 squared plus 3 squared plus negative, or 7 minus negative 3 becomes 10 squared there. Going ahead and squaring each of those. Negative 7 squared is 49. 3 squared is 9. And 10 squared is 100. So this would be equal to the square root of 49 plus 9 would be 58, plus 100 would be 158. If you wanted the exact answer for the distance between those 2 points, there's the exact answer, the square root of 158. If you want it maybe rounded to the nearest hundredth, we'll go to the calculator and compute that. So let's go ahead and do that now and figure out what this is approximately equal to, rounded to the nearest hundredth. But again, the exact answer for the distance would be the square root of 158. Okay, so we were going to go ahead and figure out what the square root of 158 was equal to, rounded to the nearest hundredth. So I'm going to my calculator now. I'm going to square root of 158 equals, rounded to the nearest hundredth, that would be 12.57. This 9 forces that 6 up to a 7. So 12.57 would be the approximate distance between these 2 points in this three-dimensional coordinate system.